Today we are going to introduce Pascal's triangle and related concepts. Pascal's triangle is a special series of data which forms a triangle like the diagram shown on the bottom left. On the left-hand side, the edge on the left-hand side is always 1. As you can see, these numbers. These numbers are always 1. The edge on the right-hand side is also always 1. Okay, these two edges, left and right, these numbers are always 1. For the rest of the numbers, for example here, the 2, the rest of the numbers is, each of the rest of number is a sum of the two numbers on the previous row. For example, 2 is the sum of 1 and 1. And 3 here is the sum of 1 and 2. And this 3 is sum of 2 and 1. Okay. This 4 is the sum of 1 and 3. This 6 is the sum of 3 and 3. And this 4, the sum of 3 and 1, and etc. We can write different rows on and on, right? And the rows can extend indefinitely. Okay. The important aspect of the Pascal's triangle is we can use combinations to correspond to each row and column. For example, if we count from row 0 and column 0, for example, this is row 0, column 0. We can use combination number C00 to correspond this number. And this number is row 1, right? And column 0. This number is row 1, column 1. Because we always count from row 0 and column 0. So we can use combination C10 and C11 to correspond the numbers in row 1. Okay, another example would be this one is row 2, column 0. This number is row 2, column 1, and this number is row 2, column 2. So we can use 3 combinations to correspond these 3 numbers in row 2. So this one is C20, and this one is C21, and this one is C22. And we can continue this process on now, right? So each number in the Pascal's triangle corresponds to combinations. Okay. Another aspect is the numbers in the Pascal's triangle corresponds to the coefficient of the expansion of binomial. For example, row 0 corresponds to x plus y to the zeros, the coefficient of this expansion of binomial. And row 1 corresponds to x plus y to the ones, because here the coefficient is 1 and 1. Okay, row 2 corresponds to x and y to the twice, because the expansion of x and y to twice is 1 to 1. Understand? And can continue this process to other rows. For example, row 3 corresponds to x plus y to the third, which is 1x to the third, 3x to twice, y to once, and 3x to the once, y to the twice, and 1 y to the third. So the numbers in the Pascal triangle correspond to the coefficient of the expansion of binomial. Okay, in general, we have this formula. Please write down this formula in your journal or notebook. This is a very important formula, and we'll be using this in our next practices. All right. So I'll write it here. Okay, I'll write it here for you. X plus y to the nth is CNN. Always start from CNN. X to the nth, y to the zeros. That's the first term. Okay, the second term is Cn n minus 1, x to the n minus 1, y to the ones. And the third term is Cn n minus 2, x to the n minus 2, y to the twice. And we can continue this process until the second to the last, which is Cn1 x to the ones, y to n minus 1. The last term would be Cn0 x0 y to the nth. Understand? Okay, I'll explain it in Chinese again. 好，请大家把这个二项式展开式记住啊。x 加 y 的 n 次幂就等于什么呢 ？CNN x 的 n 次幂 y 的0次幂加上 CNN 减1 x 的 n 减1次幂乘以 y 的1次幂加上 CNN 减2 x 的 n 减2次幂 y 的2次幂，一直加到 CN1 x 的1次幂 y 的 n 减1次幂，然后最后一项是 CN0 x 的0次幂 y 的 n 次幂，也就是说每一项都是前面一个组合数，然后 x 的多少次幂 y 的多少次幂，对不对？组合数是从 CNN 减1 CNN 减2一直降到 CN0 的， x 是降幂的，从 x 的 n 次幂一直降到 x 的0次幂， y 是升幂的，从 x 的0次幂一直升到 y 的 n 次幂，这个就是任何一个二项式的展开式，明白吗？把这个记住啊，记在你的笔记本上。Okay, any questions? Okay, write down this formula on your notebook. And then we'll see some examples. Okay, let's see an example. I'll write this example for you, okay? And leave the others for yourself to solve. Okay, so we use this formula to expand x plus y to the third. Okay, the formula tells us xy to the nth is Cnn x n y 0 plus Cnn minus 1 x n minus 1 y to the 1s until have Cn1 x1 yn minus 1, and the last term is Cnn x0 y to the nth. So if we use this formula to expand this binomial, we have C33 x to the third y to the 0, and the second term is C32 x twice y to the 1th, and the third term would be C31 x to the 1th y to the twice, and the last term is C30 x to the 0th y to the third. And we need to simplify, right? C33 is 1, so the first term is x to the third. C32 is C31, actually it's 3. So the second term is 3x to twice y. And the third term is C31 is 3x y to the twice. The last term is C30 is 1, x0 is 1. So only have y to the third. This is your final result, right? This is a concrete application of the binomial formula. You have any questions? Okay, if you know how to expand this binomial, you will be also knowing that, for example, I replace 3 here as 10. You will be also be able to write the expansion of this binomial, no matter what the number here, right? Okay, so let's do a practice. I'll give you 5 minutes to expand this binomial, x plus y to the 5th.
没有抓下。
Okay, have you finished? Let's try to expand this binomial using the formula we have learned, okay? So x plus y to the fifth is c5, 5, x to the fifth, y to 0. And the second term is c5, 4, x 4, y to the ones. Third term would be c5, 3, x to the third, y to the twice. The fourth term would be c5, 2, x to the twice, y to the ones. And then c5, 1, x to the ones, y to the fifth. The last term would be c5, 0, x 0, y to the fifth. Okay, so we need to simplify. The first term is x to the fifth. The second term is 5x to the fourth y. The next term is 10, x to the third, y to the twice. Next term is also 10, x to the twice, y to the third. Next term is 5x, y to the fourth. And the last term is y to the fifth. Right? Any questions? No? Okay, let's see another practice. Use Pascal's method to complete the array. Okay, here's the array and it's part of the Pascal's triangle. Okay, part of Pascal's triangle. And what is A? What is B? And what is C here? I'll leave you 2 minutes to complete it. Okay, have you finished? All right, let's see the solutions here. Because it's part of the Pascal's triangle, so according to the rules in Pascal's triangle, we have 1001 is 286 plus b, right? So we can have b, which is 1001 minus 286 is 715. And then we have a is the sum of 78 and 286, which is actually 364. Then C is the sum of A and 1001, which is 364 plus 1001, which is 1365. Right? Okay, any questions? No? Okay, let's move on. Okay, next quick quiz. So first three terms in the expansion of x plus y to the seventh are, okay, it asks you to write down the first three terms. Okay, I'll give you 2 minutes to finish this task.
这种题目要写公式吗？我可以直接写答案吗？
You don't need to write down the formulas. You can directly write your answers here.
OK。
Okay, let's try to write down the first three terms. Okay, x plus y to the seventh, according to the formula, which is c77 x to the seventh, y to the zeroth, and c76 x to the sixth, y to the ones, and c75 x to the fifth, y to the twice. And because it only asks you to write first three terms, so we can omit the rest of the terms. Okay, after simplification, we can get x to the seventh, and c76 is actually c71, right? c71 is 7. So second term is 7x to 6 and y. And third term, c75 is c72, which is 7 by 6. which is 21, okay? 21 x to the fifth, y to the twice. Okay, so this is your first three term. Okay, any questions? No? All right, let's see the next one. Here we have 4 questions. Use Pascal's triangle to expand and simplify. Okay, I'll give you 10 minutes to finish these 4 small questions, okay? Right, have you finished? Okay, let's try to solve them together, okay? Question A, I will not write question A because it's too long. I'll leave this to you, all right? Okay, let's start from question B. Okay, x minus y to the fifth, which is actually x plus negative y to the fifth, right? So we can use the same formula, which is actually c5 x to the fifth minus y to 0. And the second term is c5 x to the fourth minus y to the 1th. The next term is c5 x to the third and minus y to the second. Next term is c5 x to the twice and minus y to the third. And c5 x to the 1th minus y to the 4th. The last term would be c50, sorry, x to 0 and minus y to the 5th. And if we simplify, we can get, right, the first term would be x to the 5th. Second term is minus, pay attention to the sign here, right? Because you have minus y to the 1th, which is minus 5, x to the 4th, and y. Next term becomes positive sign again, which is 10 x to the third, y to the twice. Next term is negative again, which is 10 x to the twice. And y to the third. Y 3 times. And the last term would be positive sign. Oh, not the last, the second to the last, which is 5x y 4 times. And the last term would be y to 5 times. Right? Okay, next question, C. 2a plus b to the fourth. Actually, we can treat it as two terms, 2a plus b to the fourth, right? Okay, the first term would be c 4, 2a to the 4 times b to 0 time. And the second term is c4 3, 2a to 3 times b to 1. And the next term is c4 2, 2a to twice, b twice. Next term is c4 1, 2a once, b 3 times. Last term is c4 0, 2a 0 and b 4 times, and which is simplified to 16a 4 times plus 32 a2 3 times b1 and 24 a twice b twice and 8 a once b 3, and the last term is b fourth, 4 times. Okay, D. x twice minus 2 to 3 times, which is, okay, I'll use the formula directly, okay? C3 x twice and then 3 times minus 2 0 times. Second term C3 2 x twice minus 2 once. Next term C3 1 x twice once and then minus 2 twice. So last term is C3 0 x twice 0 and minus 2 3 times, okay, which is simplified to x 6 times minus 6 x 4 times plus 12 x twice and minus 8, right? Any questions? No? Okay, let's practice another one. Expand and simplify. I'll give you 2 minutes, 5 minutes to finish this.
老师，我可以再看一下上一页吗？
Okay.
好的，谢谢。
No problem. All right, have you finished? Okay, let's write this together. Okay. Question A. Expand this binomial. So P minus 1 over P to the fifth, which is C5, 5, P 5 times minus 0. And the second term is third term is fourth term. Fifth. Last one. Okay. By simplification, we have P 5 times. Should be plus. Okay, next one. B. Okay, which is okay. I'll leave the rest of the work to you. Okay. And So basically, this is an expansion of this binomial. Okay, any questions? No? Okay, let's see the next one. If there are 23 terms, if there are 23 terms in the expansion of a minus 2 to 3k minus 5 times, the value of k is what? Okay. Now the question is very simple, right? Because, for example, if we have x plus y to n times, we have n plus 1 terms, right? So now we have a minus 2 to 3k minus 5 times, then we should have 3k minus 5 plus 1 terms, right? And it also tells you that there are 23 terms. Then we have a formula like 3k minus 5 plus 1 is 23. And then we can find k is actually 9, right? So this is a way you calculate the value of k. Okay, any questions? No? Okay, let's see the last quiz. What is the total number of subsets of a set of 6 elements? Okay, for example, if we have a set, like, for example, if we have a set like A, B, C, D, E, F. Okay, example. What is set A? What is the number of subsets of A? That means how many subsets can you write? How many subsets of A can you write? Okay, hint. I'll give you a hint. A is a subset, right? Okay, B is also a subset. Okay, C is also a subset. And we choose any 2 elements. This set is also a subset, right? Or AC is also a subset. Or if we choose any 3 of them, form a new set. This set is also a subset. And we can write subsets like this. So the total number of subsets of A is the total number, the sum of these numbers, right? Okay, I'll leave you 5 minutes to complete this task. All right, have you finished? Okay, let's try to calculate the total number of subsets, okay? If the subset has no elements, how many subsets are there? We have C60, right? That means you choose 0 elements from A, from the 6 elements, right? And if the subset has only 1 element, how many subsets are there? That means you choose 1 element from the 6 elements in A. Such set is a subset of A, right? And if the subset have 2 elements, how many subsets are there? Of course, there are C62, right? And if the subset has 3 elements, how many are there? That's C63, and etc. We can add all these numbers up. Okay, of course, C66 means A itself, right? Because we choose all the 6 elements from A to form a new set, that is A itself. A itself is also a subset of A, right? And we add these numbers up. This is the total number of subsets of A. Okay, there's a quick way to add these numbers up, which is 1 plus 1, 2, 6. Can you see why? Because we have this binomial formula, right? X plus y to the n times, which is cnn xn y0 plus cnn minus 1 xn minus 1 y1, etc. until cn1 x1 yn minus 1 and cn0 x0 yn. If we let x is 1, y is 1, and insert these 2 values into this formula, we have 1 plus 1 to the nth is cnn plus cnn minus 1, etc. until cn1, cn0. So cnn plus cnn minus 1 plus cn1 plus cn0 is always 1 plus 1 to the n times, right? So here we have n is 6. So the sum of these terms is 1 plus 1 to 6 times, which is 2 to 6 times, which is 64, right? Any questions? So conclusion is there are 64 subsets. All right, if you have no questions, today's class is over. And please remember to download today's homework and submit it in time, okay?